Let f of x be equal to 1 over 4 x power 4 minus 8x. Use the first derivative test to find any relative extrema of the function. Use your graph to verify your answers. So the question is saying use the first derivative. So we need to find the first derivative. F prime of x is equal to x power 3 minus 8. And then to use it, we need to equate it to 0 so that we find the turning point. So x power 3 minus 8 is equal to 0. It gives us x is equal to 2. So here we only get one value, x is equal to 2. And then we substitute it back in the function. So f of 2 is equal to 1 over 4, 2 power 2 multiplied by 2 power 2 minus 8 by 2. So that we get 4 minus 16 is equal to negative 12. So the point is 2, negative 12. Now we're using the first derivative. So this is just 2 to the power 4. So just separated this so that it could cancel. One of them could cancel the 4 which is down. And then we remain with one of them. Then to use the first derivative, we need to test. So we have 2. So let's see if 2 is a maxima or minima. So we'll test what happens after 2. Let's say we get 3. Or before 2, we get 0 in the first derivative, which is f prime of x, which is equal to x3 minus 8. So when x is 0, we get negative. And when x is 3, we get positive. Now, when it is negative, it means that it's decreasing, and then positive means increasing. So this means that our point is the minima is a relative minima. Let's say relative minima use your graph to verify. So let's sketch it and see if it's true. So we have 2, negative 12. This point here as a turning point. But if we equate the function to 0, we must get the x-intercepts. So we'll have 1 over 4 x power 4 minus 8x is equal to 0. Multiply throughout by 4, we'll get x4 minus 32 x is equal to 0. And then we factor out x. We remain with x3 minus 32 is 0. So x is 0 or x cubed is 32. So we have 0 or the cube root of 32. So it looks like this graph is going to look like a quadratic graph. It only has one turning point and two intercepts. So this means that this point is not just a relative minima, but it is actually the minimum point. When we say relative, we mean there could be other numbers bigger than it, less than it down. But from the graph, we are seeing that there's completely nothing that is down. Everything is up. And that's how we answer this question. Any questions? No questions. Okay, let's go to question 6. Let f of x be equal to x plus cos x. Find endpoints of inflection of the function in the interval 0 less or equal to x less or equal to 2 pi. Find endpoints of inflection. Now we understand that the points of inflection, we need to get the second derivative. So first derivative, we have 1 minus sine x. And the second derivative, we have negative cos x. And then we equate it to 0. We equate this guy to 0. So we have cos x is equal to 0. In that interval, cos is 0 when x is pi over 2, which is 90. And when x is 3 pi over 2, which is 270. So these will give us inflection points. So I'm going to say, so when you get this, you go back to the original question and say f of pi over 2 is pi over 2 plus cos pi over 2 is 0. So we just get pi over 2 comma pi over 2 as the first point. The second point, f of 3 pi over 2 is equal to 3 pi over 2 plus cos 3 pi over 2. But this is 0, so another point is 3 pi over 2 comma 3 pi over 2. And that's how we answer this question. Any questions? Okay. We go to question 7. Question 7a, find the second derivative of the following. Y is equal to 2x squared plus sine 2x. So first thing is to get the first derivative. That is 4x using power rule plus cosine 2x multiplied by 2 using chain rule. Then to make it the second derivative, we differentiate this very function. So we have 4 plus, in fact, it will be minus 4 sine 2x. Again, chain rule. So differentiate cos first, it will be negative sine 2x, and then differentiate 2x. So get 2, then 2 times the 2, that is outside cos, we'll have 4. And that is our second derivative for that function. Y is equal to cot x. What is the derivative of cot? I've forgotten, but it's like we found it using quotient. So if you have also forgotten, then you need to drive it. So we know that cot is the same as cos over sine. So if we let u to be cos, its derivative will be negative sine. If we let v to be sine, its derivative will be cos. And so u prime v minus v prime u over v squared. This is going to be negative sine multiplied by sine minus cos multiplied by cos, everything divided by sine squared. But this is negative sine squared minus cos squared over sine squared x. So get negative sine squared x plus cos squared x over sine squared x. So funny. So I have negative 1 over sine squared, meaning that the first derivative is negative cosec squared x. Wow. I'm forgetting this. Okay, then the second derivative, we have to differentiate the first derivative. The best way is to differentiate this very one.
Before you go ahead, I'm sorry, just the just the way it's second. Now how are we simplified it to end up with this? And we canceling like the sine squared x sine. Okay, how did we end up with the one that you just?
So remember, remember that at some point in trigonometry we mentioned that there was the most important identity.
Yes.
Which is sine squared x.
Sine squared x plus cos squared x is equals to 1.
And that is our numerator.
Okay. Okay, thank you.
Okay. So now we differentiate this using quotient rule. So y prime prime is going to be let's be slow. So u is equal to 1. So u prime is 0. In fact, it's negative 1. So v is sine squared x. So v prime is 2 sine x cos x. So when we come here, we'll be like u prime v 0 minus v prime u, so it will be plus. So we'll have 2 sine x cos x over sine squared x sine squared x. Maybe this guy can cancel one of the signs here. And so our second derivative is going to be 2 cos x over sine 3. So now, to be a bit smart, we'll say sine x sine squared x, so that we can write it as 2 cos over sine is cot. And then 1 over sine squared is cosec squared x. So this becomes our derivative. So I've separated them this way. This guy here, and the other one I've given it a 1. So that we have a simplified version of this solution. Okay, so we go to if you have no questions, we can go to C. C, y is equal to x over 1 minus x squared. So we let u be x, its derivative will be 1. We let v be 1 minus x squared, its derivative will be 2 1 minus x multiplied by negative 1, meaning we'll have negative 2 plus 2x. Yes, when you expand there, so the first derivative is going to be u prime v minus v prime u over v squared. So we have u prime 1, v 1 minus x squared minus v prime negative 2 plus 2x u x, everything over 1 minus x to the power 4. We can simplify the numerator, that is 1 minus 2x plus x squared plus 2x minus 2x squared over, we'll leave this guy as it is, so that we get negative x squared plus 1 over 1 minus x to the power 4. Here, we let u be 1 minus x squared, v be 1 minus x to the power 4. U prime, negative 2x. V prime, 4, 1 minus x to the power 3 multiplied by negative 1. So to get the second derivative, we have u prime v minus v prime u over v squared. U prime is negative 2x, v 1 minus x power 4 minus, so it will be plus because of the minus that is there. So plus 4 1 minus x to the power 3 1 minus x squared. Everything divided by 1 minus x to the power 8. When you square, that's what we get.